Hello, and thank you for joining us for our latest Car Design News webinar, Bring On the Bling. My name is Eric Galina, and I'm the editor of CDN. Today, Michael Martens, Product Marketing Manager for Osram Opto Semiconductors, will shine a light on the use of LEDs in exterior lighting. Michael will demonstrate how, freed from the constraints of traditional incandescent, halogen, and discharge lamp sources, LEDs provide the design opportunity to be different. Michael explains why they are jewels that can make a vehicle sparkle. Michael has 25 years of experience in the automotive industry with a primary focus on marketing, sales, and quality. Prior to Osram, Michael held positions with Collins and Eichmann Corporation, Textron Automotive, Cooper Automotive, and Chrysler Corporation. He holds a Bachelor of Science from Michigan State University and an MBA from Wayne State University. The session will last around 45 minutes or so, and we hope you find this webinar stimulating and informative. I'll now hand it over to Michael to begin his presentation. Thank you.
Thank you, Eric, for the introduction. I'd also like to thank our listeners for taking time out of their busy schedules today to spend some time talking with us about automotive exterior lighting. So LED adoption is increasing in automotive exterior lighting. And today we'll find out some of the driving reasons behind that. Our review today We'll go through a brief overview of the history of automotive exterior lighting, some of the LED technology itself. We'll then go into some of the lighting applications and then conclude with future possibilities with LEDs. Osram Opto Semiconductors has been an automotive lighting leader for over 85 years, and we can trace our history back to the origin of the incandescent light bulb. From the mid-20s with the introduction of the Bilux dual filament headlight, Osram has been an industry leader in the automotive industry and continues to be an innovation leader. Winner of many automotive awards, our latest award is the 2011 Automotive News PACE Award for our Osram OSTAR headlamp device. Osram also offers the broadest portfolio of automotive lighting technology, including today's traditional light sources. This includes incandescent lamps, high-intensity discharge or HID lamps, halogen lamps, which are used for forward lighting, and the newest addition to our standardized systems is our Joule system, and we'll talk more about that later. Osram also offers the broadest portfolio of LEDs in the industry. With a wide variety, we offer discrete components and systems. Shown below are a few of the packages that are offered, from a couple lumen devices up to 1,000 lumen plus devices used for demanding headlamp applications. I'd also like to point out that all our automotive LEDs are Automotive Electronics Council or AEC-Q 101 qualified. This means the ultimate in durability, reliability, and performance for today's demanding automotive applications. Automotive exterior lighting has played an important part in the automobile since the beginning of the automobile. From the first acetylene headlamps in the 1880s, let's fast forward to halogen bulbs introduced in the 1960s. Technologies have improved and light source performance have improved. But all along, styling has also been an important factor. This was evident with the 1936 introduction of hidden headlamps in the cord and 1938 introduction of fog lamps. In the mid-80s, aerodynamic composite headlamps were allowed and legalized. This is the forerunner of today's current and custom automotive headlamps we see on vehicles today. In the mid-1990s, LEDs were first introduced in CHIMSL applications, the center high-mounted stop lamp. Since then, LED adoption has continued to grow significantly in signal lighting and in the interior of the vehicle, and most recently, over the last few years, seeing more and more LED applications for forward lighting applications. So we look to the future and say, what are the possibilities? What is it that's driving the trends to LEDs? Automotive exterior lighting or forward lighting is key to creating the consumer emotional appeal to the vehicle. I've heard headlamps described as the eyes to the soul of the vehicle. So it's the emotional appeal that we want to drive the consumer to the dealership, and at the dealership, the interior of the vehicle can close the sale. Current applications of forward lighting utilizing LEDs include daytime running lamps, fog lamps, headlamps, and front turn lamps. These also represent the traditional requirements, or most of the requirements for legal FMVSS or SAE and ECE requirements. On the signal lighting side, we see LED adoption across a multitude of applications. So what are the driving factors for LEDs? By far, the primary factor is styling and aesthetics. LEDs offer a new dimension not previously available to stylists, designers, and engineers. This allows unique brand identification and the ability to create signature looks that were never before possible. And this is particularly true at night. Aside from the styling and aesthetics, there's also performance benefits associated with LEDs. They give us a more realistic daylight color. It makes for a more pleasurable driving experience to the driver. The color of the LEDs aligns more closely with the way our eyes perceive light at night. And because LEDs are directional light sources, it gives optical engineers a better opportunity to control that light and eliminate any distracting stray light that can be associated with traditional sources. They're also low power consumption. They offer higher output in terms of efficacy and enhanced safety, and they're environmentally friendly. Let's take a brief look at the LED technology itself. How does an LED work? Well, an LED is a semiconductor device. So unlike a traditional light source, an incandescent bulb that has a filament, or a HID lamp which actually has an arc as the light source, there's no filament or arc source in the device. When currents pass through the device, light is generated from within the die itself. This light is emitted from the die and out of the package. LEDs also emit in color. This is unique compared to traditional light sources. So they will emit in the required red for stop and tail applications. They can also emit in the required amber or yellow color. So no longer do we need colored lenses to create the colored look that's required for the vehicle. Just taking a brief look at the comparison of the technologies, we see incandescent, halogen, the high-intensity discharge, and LEDs. You can see that the efficacy, or lumens per watt, of LEDs are significantly higher than traditional technologies. This allows us to make more effective use of the power that's created from the vehicle and the electrical power that's needed for the lighting function itself. And LED's lifetime is also significantly higher than traditional sources. This gives us the ability to do true life-of-vehicle performance, which can't be realized by today's traditional technologies. If I look at the optical efficacy or efficiency, the directional nature of the LEDs, the way that they emit, versus the 360-degree nature from traditional light sources, allow us to also have improved optical efficacy, which improves overall system efficiency and allows us to control and manage that light much more efficiently. Additional benefits of LEDs is that they have no filament to break or fracture. They're highly resistant to shock and vibration. Their small size enables new applications and designs. You can put light where you could not previously put it. So there's benefits in terms of packaging, also with light guides and the ability to do 3D configurations to give a lamp a unique look and depth. They emit without the use of filters. We mentioned that earlier. And they're virtually instant on. So what this equates to is increased safety and stopping distance. At highway speeds, this equates to about one vehicle of additional stopping length. Think of how many accidents could be prevented or may have been prevented with that additional stopping distance. They're environmentally friendly, so they're RoHS compliant. There's no mercury in them, and if the entire U.S. fleet was switched over to LEDs, there's the potential to remove 3 trillion pounds of carbon dioxide annually from emissions, a significant amount. Other benefits of LED, we mentioned the efficiency savings. So aside from the power savings, there's also the opportunity for weight savings and increased miles per gallon. Because LEDs don't require as much current and current draw as traditional sources, wiring harnesses, the size of them, and the associated weight of that harness can be reduced significantly. The reduced weight can directly translate into more miles per gallon. Especially important as the CAFE requirements, or corporate average fuel economy requirements, continue to increase ever higher. And because LEDs are directional emitters, there's no need for collecting light in a 360-degree area. So traditional sources, as depicted in the pictures below, emit light in all directions. This requires that we collect that light in order to control it. With an LED, it emits directionally, so it emits facing out. So already we have the light going in a direction of where it's much easier to control. LEDs are gaining, LEDs are in their early adoption for forward lighting, but they're gaining momentum rapidly. The emotional appeal that headlights and LEDs can create to buyers and help drive that traffic to the dealership is important. When we look at traditional or current headlamps using traditional light sources, a reflector optics approach is a typical approach, a very common and the most common approach. Here, the light source, a bulb or the discharge lamp, sits in the middle of a surface, a parabolic shaped surface, and is needed to collect all that light that's coming off in those 360 degrees and then redirect it into the far field beam pattern required and dictated by law. While you can have shape and size differences, the looks are all very similar. So there's not much of an ability to create unique signature looks to the vehicle headlamp. This is particularly true at night when the lamp is lit and that bright intensity from the light source itself kind of washes out a lot of any of the shape or differentiation that you might see during the day. Another optics approach is a projector optics lamp. In this, the light source is in a ellipse or another parabolic kind of collector, much like the reflector optics approach. But the function of this reflector is to collect the light and focus it through an additional lens, which then shapes it into the far field beam pattern. In between, you could have a mechanical shield or shutter to create not only the horizontal cutoff, but it can also be used to create the high beam, low beam beam patterns. So while this offered designers and stylists another look, another technological approach to creating a headlamp, it still is fairly limiting in the fact that all projector lamps will tend to look alike. On the right is a Cadillac Escalade Platinum headlamp. This is an all-LED headlamp, the first SUV with an all-LED headlamp. In it, we use LEDs as light sources, but we utilize the projector optics lamp approach to it. So while it's unique in the fact that it has an LED headlamp, the look is somewhat similar to projector lamps that utilize either halogen lamps or HID light sources. LEDs, because of their directional nature of the emission, offer us expanded possibilities. So since they're directionally emitting, as shown by the red rays of light, you can put a lens directly over it and use that to control the light, as shown in the two examples above. You can also use LEDs with the projector technology. We saw this on the Cadillac Escalade on the previous slide. So we get all the benefits of the projector lamp of LEDs in terms of performance benefits of lifetime, color temperature, the durability, the reliability in that. But from a aesthetic and styling standpoint, that lamp will still look like a projector lamp. So some opportunities for differentiation, but not as significant. On the right, we see light guides. These are typically used for daytime running lamps. In this, light is injected into a light guide, typically a plastic made out of an acrylic or a polycarbonate. The light bounces through it, and then based upon some optics and some geometry on the back is then emitted out. We'll see more about light guides as we talk about daytime running lights. Reflector optics designs can be used with LEDs, but unlike reflector or unlike halogen or HID technologies, the reflector that's needed is much smaller in terms of shape and size. In the traditional approach, we've got a collector, a parabolic collector that kind of encompasses in a largely 360-degree area the light from the light source. With an LED in the directional emitter, we need only a portion of that parabola, and it offers up new opportunities for mounting. So we can mount it from the top, we can mount it from the side, and we can mount it from the bottom. And again, the small nature of only needing a portion of that parabola allows us to achieve some unique looks that can't be done with the traditional technologies. So it gives us the ability to create innovative styling and differentiation options. Let's take a look at how this might be implemented. So in this picture, we see 3 headlamps, all same shape, same geometry from an overall standpoint. But on the left, we see kind of a traditional implementation of the low beams in utilizing a round element for the headlamp itself. On the right, we see a different approach. We have a more vertical elements introduced and also additional element sizes, so to give the headlamp a different look. In the picture on the bottom, we've chosen to take a lower profile but more linear look to the lamp to give the low beams a very linear, very elongated look. When we move to the high beams, we utilize the same approach to keep the overall lamp design harmonious. So on the left, we see a right. On the upper right, we see more integration of the vertical elements and some differentiation there. And then on the bottom, the low profile, more elongated approach. I mentioned the quality of the light of an LED versus a halogen lamp or traditional sources. So on the left, you see a traditional halogen lamp. You can see kind of the more yellower light. On the right, we see an LED headlamp. And the bluish or cooler nature of the light gives us a better perception at night and aligns more closely with our eyes. You also see that by utilizing the directional nature of the LED technology, we can offer more spread and more coverage in the beam pattern. So we see a wider beam pattern, more control, a more smooth and blended look down the road, something that as consumers we find much more pleasing to drive behind than narrower and more spotty and less blended lights. Daytime running lamps, or DRLs, while they're mandated in multiple parts of the world and in countries, they're not required in all. But what we're seeing is automakers adopting daytime running lights as the ability to introduce unique design and styling for the vehicle and for the lamp. So we see styling, branding, and vehicle bling functionality that's causing automakers to incorporate LEDs, even though in regions they may not be required by law. So the opportunity is to create a new signature look, and particularly, again, at nighttime. So during the daytime, we have one look, but at night, we get a different look and one that's very discernible and recognizable. So that signature look at night is key. There's also the potential to combine multiple functions. So You have a daytime running lamp function, you have a position, and you have your turn signal function. There's opportunities now with LEDs where we can combine those functions, potentially some cost save, and eliminate what were traditionally separate lamps. So how might we implement daytime running lights? In the picture on the upper left, we see a light guide. So I mentioned a light guide is a molded piece of plastic. It gives us the ability to create unique shapes and contours. Light is traditionally injected at the end. It'll give us a very even and neon-esque kind of look through a light guide. In the picture on the upper right, it's an approach that we're calling a blended. Similar to the light guide, it's injecting into a piece of plastic, but as opposed to the end, we're injecting from the back of the light guide and in maybe multiple places. So what we have with that is the ability to have a little bit of a different look. It's not the neon-esque kind of look. You may see some hot spots and then some little bit darker spots between the LEDs along the way. But it gives us even more opportunities for creating 3D shapes and creating and implementing complementary functions or implementing additional functions into a common lighting element. In the picture at the bottom, we see kind of a point source. This is what has historically been the implementation. We've utilized LEDs. They've been discernible in some kind of a matrix kind of display or a pixelated display as a way to also convey the uniqueness of the lamp. So that approach is still possible. Three-dimensional shapes can be achieved there through the use of flex circuits, putting the LEDs on a flexible circuit, and then that would be mounted to some kind of carrier, but give us that unique look. So, from a front turn signal approach, you could utilize the same approaches, either a light guide kind of approach we're showing on the left, or you could have unique shapes and elements that you couldn't do with a traditional bulb, incandescent bulb. The bulb, much like a headlamp, requires some kind of a reflective surface, parabolic kind of surface, so the ability to create unique shapes is limited. And with LEDs, you could also implement a point light source if you desired from a turn signal standpoint. I mentioned earlier about the potential to combine functions for the daytime running light. Here, we're depicting and showing a light guide. It has light injected into it at 2 points along that complete element. And this is showing the daytime running light feature. You could also use this as a position light by just turning down the intensity. But you can also turn that into a turn lamp. So in addition to the white light that's required for the DRL function, you could introduce amber or yellow light into it for a turn function. So we could achieve a very unique look, a daytime running light, turn signal light combination, and also we've had the ability then to eliminate the separate function as a separate DRL and separate turn. So what might this look like if we were to actually implement it into a vehicle? Well, shown on screen is an Audi A8 with a full LED or all LED headlamp. Shown on screen is the daytime running light. It's utilizing a blended approach. You can see some brighter spots and then separated by some darker spots. So with this LED, we're injecting light into the back of it, but you can see a very unique shape to it in its appearance. We also are using that lamp for a turn lamp. So we're utilizing the same element shape and look, but we're introducing the yellow lamp as the turn lamp, so you can see that we can get a very distinct look. Again, particularly at night, this is very distinctive. In the elements immediately above that is the low beam. You can see that the low beam is made up of 10 individual elements. The optical approach was a optics directly over the LED, which can be done because it's a directional emitter. This couldn't be done with traditional technologies. But you can see a very unique unlit appearance, and then the lit appearance that carries through into the lit appearance, very distinct. easily recognizable either as you're oncoming, approaching the vehicle, or if the vehicle is approaching from behind you in your rear view mirror. So these individual elements are all combined to make up the low beam requirement. Immediately above those, you'll see 3 cavities, and those are going to be the high beam application. So the high beam is utilizing a reflector optics approach, a very simple, very effective, and efficient optical approach. It has 3 distinct cavities, which the LEDs are mounted on top and emit downward on it. And you can see that the unique shape of the high beam follows the overall contour set forth by the daytime running light and that element. Here's the lit appearance of the high beam, and you can see that those individual cavities kind of wash out. So that's the same general effect that happens for all the traditional reflector optics headlamps. So that's where those lose some of their distinction. But you can see that in this case, we have the unique shape of the high beam nicely aligns with the overall shape of the low beam and the flowing form factor set forth for the overall lamp. A very good implementation, taking full advantage of the uniqueness of the LEDs and the styling opportunities. So if we look at signal lighting, it's nonetheless exciting. It's further along in its adoption, which was based upon the ability for the LED technology. But let's take a little more deeper look into signal lighting. As with forward lighting, the trends that are driving it is the ideas and desire for signature looks and styling and differentiation on it. With LEDs, we're seeing lamps move from more 2D designs into more 3D designs. This gives the lamp some additional depth and shape and contour, perhaps some inner lens with that to add to that. Also, the increased adoption of light guides. So we'll see light guides often for a tail function, which has a lower output requirement, and then we'll see additional elements or perhaps even backlighting behind that from individual LEDs for the stop and turn functions. We're also seeing the functions themselves being more segmented. So in traditional incandescent technology, we often have the same lighting element, and from tail to stop is only the difference of a darker or higher brightness filament. In the case with LEDs, we're seeing that more segregated. So the tail function is a separate set of LEDs and a separate approach, separate elemental approach. And with stop and turn functions, then we have the ability to introduce additional styling elements, additional functions, or a segregated function. So in the tail lamp, let's see how those might be implemented. In the picture on the left, we see a light guide implementation. This is a very even, again, neon-esque kind of approach with a light guide, but we've got some ability to also do some very unique shapes and tight turns with it. On the picture on the right, we see the more traditional, or what's been more common so far, has kind of been the pixelated look. Individual LEDs, you see those, each light source, they're distinct, highly identifying that it's an LED as a light source and not some traditional source. So with this, there's the ultimate in terms of three-dimensional shapes and unique shapes in that by the ability to utilize the individual LEDs. In the bottom, we're looking at LEDs going through a lighting element, let's say into a light guide or into a lens, somewhat similar to the blended approach that we saw in the forward lighting, but in very unique shapes. Again, something that you couldn't do with the traditional incandescent technology, which requires a bulb and the area for the bulb and then a collector surface to get the light and redirect it and focus it. You could also take a approach with the pixelated look where it can be blended so that you would not see individual sources, but they could be grouped close enough that basically they would blend together into one homogeneous appearance. When we move to the brake function, which needs to step up in intensity, in the picture on the left we've introduced additional elements. So we've got the opportunity to not only discern between intensity difference between the two functions, tail and stop, but now we have the ability to introduce an additional lamp function segregated out, and then also unique styling elements, or how that light may look. On the lamp on the right, we've gone with a just more of a lower profile, elongated approach with LEDs, more homogeneous. And on the bottom, we've utilized the same lighting element and also and only introduced a higher intensity. So in broad approach, that's typical or similar to today's traditional lighting approach, where we just utilize the same element that's there and then step up the intensity. But again, the uniqueness in the shape is available to us. So when we look at turn signals, the same thing. We can carry through some of the lighting elements in terms of form factor as with a brake light. So we're depicting that with individual elements on the left, and on the right we've got the horizontal approach to it. And in the picture on the bottom, we're utilizing that center area within the tail stop outer element to use for the turn signal function. So with LEDs, since we said the LEDs emit in color, we can also have various colors of red that we may introduce into the vehicle. So for instance, in a tail application, we could have a darker, deeper color red, still all compliant and within the regulatory requirements from the SAE or ECE for a light guide application. Then when we move to the brake light function, we not only can have a step up in the intensity to identify that the vehicle is stopping ahead, but we can now introduce also a different color red, perhaps more of a reddish orange, that would also offer greater differentiation between the standardized or one color of tail brake lights that exist today, particularly with incandescent technology, where we're utilizing an outer lens in red to convey the color, to change the color from the white light to the red that's visible. So this can be particularly beneficial too in the fact that with LEDs, and since they emit in color, we no longer have to have a red outer lens or a yellow outer lens on it. The outer lens can be clear. That opens up the lamp, the styling of the lamp to draw the attention into the inside of the lamp. You can have some greater decorative approaches to it, perhaps draw your attention through the uniqueness and a three-dimensional shape that's there. From a turn signal, again, we can utilize the same lighting element shape, or we could introduce a different shape. And that could either be a yellow or amber turn, or it could be a red turn, depending upon the region that you're in. So the possibilities from a styling and aesthetic standpoint are really unlimited here by utilizing LEDs. So here's a simple adoption. I don't think it's quite showing through on your screen, but this is a current Mustang utilizing a Joule, one of our Joule technologies. It's a sequential turn. So the cavity, the inboard cavity on the left comes on first, then followed by the middle cavity, and then the outer cavity on the right. So you have the sequential lighting of the lamp, so it gives a very unique appearance in a very simplified way with one of our Joule standard technologies and utilizing a simple reflector optics technology. So we saw the Joule used on the Mustang tail lamp on it. Let's talk a little bit more about integrated or standardized LEDs. Effective implementation of LEDs requires the management of four basic characteristics: a mechanical, thermal, optical, and electronic control of the LEDs. And a standardized or integrated system does that and makes it more of a plug-and-play system. So much like today's traditional light sources, which are plug-and-play, you bring up the vehicle 12 volts to it, or from the vehicle architecture, you plug it in, and it performs in a certain manner. With our Osram Joule product, we've developed a product that does the same thing. We take advantage of LEDs and all the performance benefits of it, and then the Joule system also addresses and standardizes the mechanical interface, the optical emission pattern, the thermal management, and the electronic control circuitry for making an effective implementation of LEDs and lighting. And the real benefit to this is the fact that now I only have to qualify a light source once. I can do my validation testing, my EMI testing, my EMC testing. It's done once. The light source is standardized and qualified. So I do not have to validate each and every design as I would with perhaps a custom approach to it. And this not only then saves cost, but it also facilitates redesign and can quicken those along. The Joule product portfolio includes devices for signal systems, forward lighting, and there's also custom modules and electronics. So should the approach be unique and utilize discrete LEDs, we also have the ability to create those custom systems for you so that we manage those characteristics, the mechanical, electrical, thermal, and electronic control interface appropriate for LED implementation. So while the systems themselves are standardized, their look certainly doesn't have to be. When we look at the picture on the left, we see with the red a simple and effective implementation of a reflector optics design with a Joule standardized system. And then above that, we see a very interesting implementation of a yellow or amber light guide utilizing a Joule, another Joule system. So while the systems themselves, the LED systems themselves are standardized, they can be implemented in such a way to be able to create a very unique and distinctive appearance. In the picture on the right, we see the same thing. It's a simple Joule system, a standardized Joule system, and so we take advantage of all the qualification, the previously qualified qualification and approval of the light sources. But in this design, we see a free-floating optics. So the optics there appear to just free float within the lens themselves. So again, a very unique and implementation by using a very simple and standard approach. So vehicles are becoming more and more intelligent, and consumers are demanding safer vehicles and more pleasurable driving experiences. And some technology that's helping to achieve that are infrared LEDs and lasers. So automotive safety is moving from passive safety, which traditionally is reactive. It manages safety after something has occurred, after an accident has occurred. So traditionally seat belts, airbags, and collapsible steering, etc. But to make greater advances in the future, we're moving towards more active safety controls. This is taking a more proactive approach in either working to prevent the accident from happening, or as it's happening, we're making a more, we're controlling the way that the vehicle and the vehicle safety systems are reacting with pre-crash sensing, traction control, and that. The European Union's got a intelligent car initiative that they support and sponsor. It's dedicated to promoting these active safety systems. I would encourage you to take a look at their website to learn more and more about these systems and their promotion and implementation of these systems in today's and future vehicles. So these are some of the active safety systems, or the the proactive approaches to it that are in application today in some form or another. Adoption is early and limited, but these are applications currently on the road today. Let's take a look at maybe one or two of these just to understand them a little bit better. One system that we probably all have some awareness of is an active night vision system. In this, we're utilizing an infrared LED or an infrared light source combined with a camera system to view down the road and objects down the road. So while there's regulations that indicate or limit the amount of visible light that we can promote and push down the road that would give us this visual acuity, there's limitations to that. So one option that we have is to introduce a night vision system, and that would be able to depict objects that we cannot see, either because it's not illuminated or because perhaps they are blending in more readily with the background. So with the night vision system as depicted here, we could see that there's some animals, some deer perhaps, and further down the road, the vehicle that's oncoming. Another technology is adaptive front lighting. In its simplest form, and where we'll see more and more applications, is LEDs used for cornering lights. So a cornering light is used to illuminate an area to the direction that you're turning. So if I'm turning to the right, the LEDs or lighting will shine to the light, show me the direction where I'm going. This is accomplished today by utilizing a mechanical system on it, in which the whole a whole lamp is turned. So the mechanical systems are not only costly, but obviously they're complex by the fact that they're mechanical. I have to have the reflector and the light source and everything turned. So there's also questions and more complexity towards reliability and durability and performance over time. With LEDs, we can set up a separate light and turn the LED on based upon input from the steering wheel control, and turn the LED on and off to give us light. Taking that idea to the next level is adaptive front lighting systems, where headlamps are automatically controlled and there's an adaptive beam pattern. The beam pattern is going to be based upon the environment from which you're driving. So for example, if you're driving down the Autobahn, that would indicate perhaps I need more far field reach down the road. If I'm driving in the city, then I don't need those lights to reach down the road. I perhaps need more spread, and I can turn lights off. The adaptive smart headlamp will recognize what the driving environment conditions are, turn LEDs on and off, turn light sources on and off to accommodate to the appropriate beam pattern for your environmental conditions. So as we look to the future, what does that hold for us? So in the near term, we're going to see more LED headlamp adoption. Certainly increased daytime running light usage, so some of that mandated by governmental requirement, but also because of styling and opportunities for styling, aesthetics, and differentiation on it. And the use of light guides and multiple light source lamps will continue to increase to give us that ability to create that unique look and that signature look, both lit and unlit appearance in lamps. As we look a little further into the future, the midterm will provide us with more adoption into more of the mass market segments for LEDs on that. We'll also see LEDs roll out into other ancillary lamps and other kind of functions. So these are lamps and functions that may not be required by law, but there are other areas that will be used to either create a signature look to the vehicle, create some increased consumer appeal, or convey additional information to the driver and surrounding vehicle. So if we think of the active safety systems and pre-crash sensing, collision avoidance, lane departure, things like that, additional LEDs and functions will be incorporated to convey what that sensing technology has identified. And the AFS functionality. So we mentioned cornering lamps. Those will become more prominent, increase consumer awareness or satisfaction and pleasurability in driving. When we look to the future, those will lead us into the smart headlamps. These are the lamps that will sense the driving environment and address the illumination to adjust to whatever that driving driving environment is. This will give us the adaptive beam patterns and take more control, move some of the control away from just on-off on lamps into more effective and more efficient beam patterns and lighting illumination. Sensor technology will continue, so the active safety systems will see more and more of that integrated into the front of the vehicle and into the lamp itself, such as the night vision, and more of the active safety system adoption. And who knows, in the future here, we'll also perhaps start seeing additional light sources, maybe with LED lasers as a light source, replacing or in addition to LEDs themselves. Looking at the future, and where can we bring on the bling to the vehicle? So we see the continued adoption in the headlamps. We'll see more and more LED headlamps. This will transition from premium vehicles and high lines into more mass market, mass segment vehicles, which will have the ability to take advantage of all the aesthetic and performance benefits associated with LEDs. We'll see daytime running lamps continue to adopt and grow. You can implement them in turn signals. We'll see more and more turn signal. Recent advances in LED technology, which have made the white lighting possible, is also helping to make turn signal applications possible. So we'll see brighter LEDs, more effective conversion into yellow light, which will make turn signals more functional and more readily adopted. Taillights, we'll continue to see adoption in signal lighting, tail lighting, the chimsel lighting, again in more and more unique shapes and styling and aesthetic looks. And so those kind of round out what is required, or what are current implementations and what's required from a legal and governmental requirement. But where can we also introduce LED lighting? So perhaps for brand logo and identification. Think of the ability to illuminate a logo, or perhaps to put a logo on the front of a vehicle that would be very noticeable and very identifiable. So both as it's oncoming to drivers, or perhaps from somebody's rear view mirror look. Many cars have some decorative side vents, either decorative and or functional side vents. Perhaps there's some opportunity to add some lighting to that and create some different looks at night, some identifiable signature looks at night. And side mirrors. So we see implementation into side mirrors today. We see some turn functions for from the front with yellow lighting. We also see more and more integration of LEDs into the mirror, into the exterior mirrors, conveying information about the surroundings to the driver, conveying information to cars alongside. So we'll see more and more opportunities to put LEDs and convey more information and messages there. So we also see opportunities with door handles. So LEDs, we mentioned their small size and inconspicuous size, and the ability to put light where you wouldn't expect it. So in a door handle, we could make it more consumer friendly by illuminating the door handle. As you approach the vehicle, it recognizes you have the key fob, or you hit the key fob button. So the entry-exit welcome can be improved and create a greater consumer satisfaction and functionality, highlight the door handle and make it aware for the consumer. You could also introduce some safety lighting or some courtesy lighting out of the door handle, illuminating the area on the ground below the door. We could look at the fuel cap or charge port. So perhaps particularly relevant with electric vehicles or hybrid vehicles. where the charge port could also be used to convey how full or how charged that vehicle is. For instance, it could be red if the vehicle is depleted, if the battery charge is depleted, and as the vehicle's charging, that could change from a red to perhaps an all green at a fully charged, and along the way, differing colors. Roof racks, the opportunity to put lighting in roof racks. So along the linear roof racks, not only from a styling standpoint, but perhaps from a functionality standpoint. As you're utilizing and using the roof racks at night, the ability to put some light up there can be quite beneficial. Wheels, well, you couldn't legally light these while driving. Wheel lighting offers the opportunity to increase the entry-exit experience for the driver and passengers. So we could light the wheel wells as a welcoming and exit from the vehicle. Under vehicle lighting, again, much like the wheel wells, were areas we can use it for entry-exit welcoming and increase the consumer experience. There's even the opportunity to perhaps customize these colors that you may see in these applications with interior colors. As the interior is introducing more and more opportunities for personalization on the inside with red, green, blue kind of colors and color mixing, then perhaps that can also carry through to some of these accent lighting or styling lighting that exists or could be introduced into the vehicle. So we could also have some welcome lighting, so increased security lighting as you enter or exit the vehicle. Think of it in a dark parking lot. You could have light emitting around the vehicle that makes it more visible and adds some safety to the consumer and to the driver themselves. So let's take a look at some concepts in LED lighting. We are working with co-sponsoring a project with Visteon, with the College for Creative Studies, with students there. The students are designing a lamps in a vehicle for a 2020 vehicle, in which they're also designing lamps and lamp concepts. So here is one student's look at differing looks as to perhaps the headlamp on the right. You can see up above they had some conceptual ideas for perhaps daytime running lights and differing colors that could be used as part of the entry and exit welcome process. In this illustration, we see a very long, linear, small light across the rear of the vehicle, a very unique look, extending across a very linear look, captures that very low profile, broad look depicted in the sketch. There could also be opportunities to light along the vertical edges of what we see as the rear fenders or the rear quarter panels. So the potential to have that same kind of very narrow linear light guide look could be introduced there. So something that you could not do with incandescent bulbs and traditional signal lighting. In this view, we're looking at a concept from a forward lighting standpoint, where we see the yellow or the orange color that could be introduced as the turn signal function for the lamp. So you could have a combination, perhaps white light, and then it goes to the amber or yellow function for the turn function. In this concept, we see very unique shapes for the headlamps, and the lighting elements within and the lighting functions within those headlamps also carry through that vehicle's overall theme and overall lines in the form factor that is drawn and shown and visualized by the student. Here's a headlamp concept. We can see a light guide implementation. It's a blended backlit light guide. You can see by the brighter point sources, but joined with the light guide itself, so a little bit darker, but kind of a contiguous. And here we see as the light guide carries forward to the inner side of the vehicle, towards the center of the vehicle, that the intensity kind of blends out. So a different interpretation, a different look. We have the very bright area to the right, and then as we move to the center of the vehicle, that kind of blends out. So we also see on the left the implementation of a yellow for the turn signal function. In this sketch, we see the shape of the lamp. We see the shape of the light guide carrying through into the overall lines of the vehicle. So carrying through that ridge coming down through the center of the vehicle, we see some lighting or the opportunity to introduce a light guide that kind of carries that line down into the and then in towards the fascia. This view, we see a very free-flowing approach. We've got the lighting integrated vertically, so a little different than traditional headlamps, which tend to be more elongated, but a very narrow vertical look for the main lighting. And then we see this very free-flowing wave kind of look associated with the rest of the vehicle. So that those leading edges of those lines could be illuminated with by utilizing some form of a light guide, or with LEDs and a very low-profile lamp design. So very conceptually interesting. In summary, LED adoption will continue to increase for automotive exterior lighting and sensing applications. So the effective implementation will enable designers and stylists to create very distinct styling options that can command attention and give us a very unique signature look, both in the lit and unlit appearance. And so there's many driving factors for increased LED adoption. So the styling, the brand differentiation, the consumer looks, the consumer wow, that emotional appeal to the vehicle that allows us to utilize the interior to create and complete the sale is a large factor. And then there's also the performance benefits. So we've got energy savings, true life of vehicle performance. The color temperature we mentioned with forward lighting makes for a more pleasurable driving experience and aligns more closer to our eyes' actual night vision. And it's a green technology, so we're saving weight, we're saving electricity that's required to be generated from the vehicle for traditional lighting today. We're seeing more efficient use, or more efficient light creation. Our lumens per watt is greater. And think of the CO2 reduction. So as we continue to move and increase LED adoption, then the emissions associated with that power consumption also are going down. So Osram Opto Semiconductor will continue to lead the way in automotive exterior illumination, visualization, and sensing. Thank you for your consideration for Osram, for your next generation automotive exterior design. If you would like to get a hold of us, feel free to contact us appropriately, either through your sales contacts or through my contact information as shown on the slide. Thank you.
Thank you very much, Michael, and thank you all very much for joining us today. This webinar will be uploaded onto our archives and accessible in future for all of your colleagues who have been unable to attend the live presentation. You can access this and any previous webinar under the Process tab on the CDN homepage. Thanks again for joining us today. We hope you'll join us again for our next webinar.